Hello, everyone, and welcome to our webinar, Teeing Off Together, Plastics and Metals 3D Printing for Golf Club Design. My name is Zach with HP 3D Print Marketing, and I'll be your host. Today, you'll hear from Katie Calderon, the creator and founder of an amazing company called Club Girl Golf, and how she is helping to change the way we think about golf club customization. Katie had an idea to create a woman-focused, custom-weighted putter, and throughout her design journey, turned to HP Additive Manufacturing Solutions to bring those ideas to life. Using both the HP Multijet Fusion polymer printer and the HP MetalJet 3D printers, she is now helping thousands of women around the world improve their golf game. And at the end of this webinar, you will receive a special offer from Club Girl Golf so you can experience their products for yourself. Also, if any questions come up during the presentation, we have the Q&A available at the bottom, so be sure to get them submitted, and we'll try to get them answered later on. So now, let's hear from Katie about her journey so far, how she's utilizing the HP 3D printers in her final designs, and what the future holds for Club Girl Golf. Go ahead, Katie.
Howdy, everybody. My name is Katie Calderon, and like Zach said, I am the founder of Club Girl Golf. You could pretty much say, though, golf has been my life. I started playing when I was 4 years old, was the captain of my high school golf team, and even went pro for a little bit on the Women's World Long Drive Tour. And back when I was in high school, I actually started working at a golf shop. So at first, I was right behind the register, and then quickly they moved me back into club repair, which is how I learned like a bunch about how clubs work and how you can manipulate them. And then I went into golf club fitting, which is basically trying to find the perfect fit golf club for each individual user. And so when it came time for me to, get serious about college and figure out what I wanted to do with the rest of my life, I knew that, golf had always made me the happiest. And I was always, I always enjoyed working at the golf shops and playing, and I wanted to find some kind of career that would combine those. And I really love tinkering with the clubs. So I decided that, I wanted to design golf clubs. So I went to Texas A&M University for engineering. And during my freshman year, you're sitting in one of your intro engineering classes, and the professor was going around the room and asking everyone like, oh, why do you want to be an engineer? And you were getting, the typical answers. I want to build airplanes. I want to build computers. And I said, oh, I want to build golf clubs. And it kind of took my professor aback for a second. And she just looked at me and said, well, I think you could do that now. And I took it to heart. And so I decided, okay, I want to try and do this. Like, can I actually build and 3D print a golf club with what I had available for me at school? So I started coming up, I downloaded a really basic CAD software, made a super simple design, and ended up posting it online and learning a bit about how to design the clubs. And then I decided that I wanted to build a club that I could actually play with. So the only club that I thought, well, if it's plastic I could play with would be a putter. So I made that first putter. Then I decided, okay, well, I need to make it playable. So I looked at all the clubs and everything that I knew from working in the golf shops and building clubs, and realized that, okay, yeah, plastic isn't heavy enough. I'll have to add these weights, and create the putter you can see there, which was my first working 3D printed putter. Still one of my favorites, still play with it when I can, but the basis for this club ended up being what I used later on in Club Girl Golf, with how you can manipulate the weight on a golf club. So I was posting my entire journey on social media. I threw up that first video and it got a few million views and a bunch of comments saying like, oh, this is how you can manipulate the design, and quickly grew my following. It's showing how I was designing these clubs and talking about equipment to over 500,000 across my social platforms. And when I was on there, I got a lot of requests once I got a working club. Hey, I'd love to buy one of your putters. I want to see, I want to play one of these clubs. So I thought, okay, if I'm going to do it for real, then I'm going to do it to address what I think was the biggest issue in the women's golf world, which is shrink it and pink it. And what shrink it and pink it means is it's the way that the majority of golf manufacturers make their women's clubs. They take their men's most forgiving golf club, chop down the height, and change the graphics to pink. And that doesn't work for the majority of women. And when I was working as a fitter, I saw that almost every single woman that I fit had to have some kind of customization done to the club to make it work for them, or we're having to buy men's clubs and have them to be extra customized. So it was costing hundreds to thousands of dollars more for women to play the sport that they loved. And that was the issue that I wanted to tackle when I decided to design golf clubs. So I did a little bit more research to see how big of an issue this was, and found that there are 6.4 million women in the US alone who golf. But over 5 million of those women are unhappy when it came to their clubs and equipment. I thought that was a huge stat. So I said, okay, I want to figure out why these 5 million women are so unhappy. I've seen it from the fitting standpoint that yes, there's an issue, but I want to know exactly what other women who play think the problem is. So I threw up a little story on Instagram to my followers and I said, hey, if you're a woman who golfs, I want to talk to you about your golf equipment and find out like what you love, what you hate about it, and just to see. And I got thousands of women responding. So I took as many of them as I could, and I, set up little Zoom calls with them, and I, talked to them about their equipment, what they loved, what they hated, what their issues were. And I found that almost every single woman had at least one, if not all three of these common issues with their equipment, which was feel, size or style, and the limited options out there. So when it came to feel, it ended up breaking down into a weight and balance problem because they were having to have the height adjusted on the club because they were maybe shorter than what it was supposed to be or taller. It ended up creating a big balance problem. And that was creating a larger miss for them out on the course or just something not feeling right when they were playing with the clubs. Then the second one was size and style. Because of the shrink it and pink it way of making clubs, there was not enough options out there for women to find a club that looked good to them and wasn't either super gimmicky or just didn't kind of fit what they were looking for. And then also the limited options. And so for limited options, I did a little bit of research into my experience with golf. And this is actually a photo of one of the putting greens at one of the golf shops that I used to work at. And you can see there's hundreds of putters up and down this putting green. But in reality, that little pink box is the women's section. So there's not a lot of options out there for women because of the way these clubs are designed. And that's what I decided to tackle when I created Club Girl Golf. Now, this is a photo. This is our debut product, the Monarch. The Monarch is the first club that I've designed in what will hopefully be a long line of golf clubs. And what's really cool about the Monarch was that it was designed to fix all of the issues that we had seen and talked about with all these women who played. The big part about the Monarch is the tech slot, which is our adjustable weight system. So how this works is we have a little slot at the bottom of the club that's actually removable. And then you have 120, you have 4 different weights. You'll get 3 of each weight, and it makes 125 different combinations. So you can actually adjust for toe, heel, and center where the club is balanced, and that'll change how you perform out on the course. So we were able to come up with this design through player testing. When I realized that this was going to be kind of the technology that I wanted to pursue to make this club for women, I reached back out to as many as I could, and I said, hey, I've got a prototype, let's try it out, and really came up with that final design through all of this testing. And in doing so, we were able to create our fitting system. So when you get this club, you will receive, the Monarch Putter itself with the tech slot, but then also all of the weights that come with it and access to our self-guided fitting system. So you don't have to take this club somewhere or go get fit or paid to get fit. You do it all yourself, either from the comfort of your home or your home course. And it walks you through step by step how to adjust the club based on what you're feeling. And then we'll adjust it for you so that we can not only find your perfect balance, but then also correct for any kind of miss that you have out on the course. So this is just a quick demo of how the fitting system works. So we have it at our starting settings, which would be, 4-gram weights on the toe and the heel and a 2-gram weight in the center. Then it'll ask you, okay, let's check your feel. You're going to hit a couple shots. You're not going to worry about where they're going. Does it feel a little bit too heavy, too light, or does it feel all right to you? And then depending on how it feels, that's how we're going to adjust it. So for me personally, I thought that the base settings felt a little bit too light. So it pushed me into a little bit of a heavier feel. So you've got an 8-gram weight now in the toe and the heel and a 4-gram weight in the center. And so, okay, that felt pretty good to me. So now it's going to check my speed. We're going to hit another 5 shots at the target, and you're going to see if it's going long or short of the hole, or if you're kind of right at where the hole's supposed to be. So I hit a little bit short, and it makes another adjustment for me while staying within the same weights. And then it says, okay, well, now we can fix your miss. Are you hitting to the right, to the left, or center? I hit a little bit off to the left, and so it creates a new weight combo for me. And the best part about this is that you'll be able to adjust it however you'd like whenever you're playing. So if in a year, a month, whenever, a day, something feels off to you, you just log back into the fitting system and it redoes the fitting for you because you already have all the components so that you can have a putter that grows with you. Now, this tech was super fun to develop. It took me a couple years at A&M using all of the programs and all of the resources from school. But now I got to the point where we had all of this that worked, and how was I going to manufacture this? Because we've been doing all the prototyping. So with the tech slot, you can see I was getting it, 3D printed and then sandblasting it and putting everything in myself. And then with the club head itself, originally we were getting them 3D printed from, little dealers that we would find online where we could get a deal and get them printed and get, our base prototype. And then once we had something that worked, we had our school fabrication lab actually make 10 clubs using a CNC machine. That way we could get them as accurate as possible to make sure, yeah, this is the design that we're going to go with. But it was ridiculously expensive. It was a bit out of our price range as a startup. And it took a bunch of our grant money, and that's what we used it towards, which was great to make sure that this thing worked, but it was not practical for a mass production. And then for the weights, the way that I was making the weights, which is probably one of my favorite photos, is I would go in either, my patio outside or my parents' garage, and I would take tungsten powder and resin, and I'd have a little scale, and I'd fill up this mold that I made to make sure that we would get, our 4 different classes of weights, which was not a practical way to keep making them. They didn't look too professional, and you could have a little bit of variance in the weight. So I needed to figure out a way that I'd be able to make these clubs and be able to produce them to the point where I could start selling. And so when I really sat down and made a list of what I wanted out of a manufacturer, there were kind of 5 main things. First was I wanted a manufacturer that could make all of our components. I wanted a manufacturer that could grow with us, a manufacturer that was affordable, a manufacturer that was understanding because we're a startup, we're students, and a manufacturer that had sustainable manufacturing processes. So when it came to making the Monarch putter, we have about 16 components that go into it, and they were all made in different ways. With the weights that we had, we were either making them with the tungsten powder, or we would have little steel that we would machine, or I'd 3D print certain components on my printers at home or at school. And then with the club head itself, that was either 3D printed or machined. But the biggest issue with making the Monarch is the hole at the bottom of the club, and that was going to be our biggest driver to finding a way to manufacture it, because it is something that needs to be so precise since everything goes inside the club head and it's kind of hollowed out inside. So it's hard for that to be produced. And so we needed to find a way that we could manufacture them that would fall within our price range that also allowed us to have a super accurate slot so that all these components could fit together. And then we also needed someone who could work with us as a startup, and because we have startup growths and startup costs. I'm super grateful for the fact that because of all the programs at Texas A&M, I've actually been able to fully self-fund the business up until now, thanks to grants and winning pitch competitions. So we were working with a bit of a smaller budget than most other places. And then also a way for us to, we wanted someone that could grow with us since we are just starting out. I wanted someone that I could start with now and they would say, yeah, if you're going to order 30 clubs or 100 clubs, that's totally fine. But then in the future, when I need to order, 5,000, 6,000, it's no big deal at all. And so that was kind of what was next for us in finding a manufacturer. And then also someone with sustainable manufacturing. I'm a senior at Texas A&M. I'm a manufacturing engineer. And so I've been learning about all these manufacturing processes. And I knew that, I wanted to have a club that could be made well, but then also do good for the environment because of the way a lot of manufacturing processes work. So it was really easy for us to go back to the printer. And we said, okay, this club definitely needs to be 3D printed. This is going to be the easiest way for us to make the club and also the best way for us to, if we need to change designs in the future and be sustainable. But we wanted to find a 3D printer that worked best for what we needed the club to do. Because we tried all of these other ways of printing and had a lot of issues. Like with this club, you can see on the toe, we've got a bunch of little scratches and dents and divots inside of it. The grooves on the face of this club were all different depths and they weren't as sharp of edges as we needed. And the logo on the heel, you can see that it's again, the depth isn't there. The lines are a little bit all over the place. There's no real straight edge on this club. Everything kind of looks scuffed up, and this is it before it got played with. So we needed to find a way to make it a little bit better, and that's when we reached out to HP to use their binder jet 3D printing processes, because we thought that that was going to be the best way that we could move forward. Now, when we reached out to HP, I originally was just looking for someone to do the metals, and I ended up finding out that they could do all of our polymers as well. So they make every single one of the components that clubs with the head. So everything that we produce and have designed is 100% 3D printed, which I think is just awesome. And they can do a whole lot more with the actual designs than we even imagined. So when it came to our metals, we use the S100 printer, and we actually use a 316L stainless steel. So we make it right within the range all the materials that we had been using prior. And what was amazing about working with HP was when we reached out and said, "Hey, we've got this putter design." They already had some experience in golf clubs, so they're like, "Yeah, this is something we can definitely do." And they put me in touch with 4 different contract manufacturers. And in talking with them, that's when I found out, "Oh yeah, you guys can do my polymers too. Amazing." But when we worked on the club head itself, they helped me to find a way to make this club that would be most cost effective and something that, as a startup, I could afford to do, and also be able to, scale up to a mass production level, which was amazing. And then one of the coolest things I think is when you actually look at the comparison in clubs. So this is a putter that we had done using SLS versus, our current binder jetted club. So you can see there's just a bunch of errors and issues that we were having before we reached out to HP to switch technologies. The like I said earlier, the slot at the bottom of the club head is the most important part of this club. That's where, all of our technology gets inserted. That's what makes everything work. And when you use a process like SLS for a part that, has really thin edges, we get, a squiggly line. Like I always say that this club looks like, a child tried to draw a straight line on a club to have our insert. So and then you can see at the bottom too, we had a lot of bowing, a lot of curves, and then the face of the club head is supposed to be flat. And if you look at the top there, you can see, again, it looks like kind of a squiggly line. And so this is something that we wouldn't be able to send out. I mean, it just wouldn't work. But then also to fall within the USGA regulations, because as a golf club company, we have a set of rules that we have to follow for equipment. All equipment has to be, produced within, a same tight tolerance range. All the clubs kind of have to be the same. So if we have one club that has a little bend here, every club has to have a little bend here. And so this is something that we wouldn't be able to mass produce and sell because it wouldn't fall within those rules, and we wouldn't want people getting in trouble playing our equipment. And then you can see with binder jet, we have, every line is perfectly tight. We've got, our logos look perfect. There's no bowing at all on the club. The slot fits in perfectly. They were able to, double check the tolerancing on this part to make sure that, yeah, this piece will go in the exact fit that you want every single time. So it was just such a difference in the club, and it has made a huge impact on our ability to produce. And then one of the coolest things I think too with the contract manufacturer we're currently working with is metal finishings. And because, the club comes out 3D printed, we can get it sandblasted and everything, but then we can also ask for finishings, and because of the manufacturer we're currently working with. So we can get the club in, a bunch of different colors with PVD dye, but then also we can get our logos painted. So the next step for these clubs is to get get our logos with all of our coloring on it and get it all painted and ready. So that way, all we have to do is throw a shaft in it, put in a little slot, and send it out to the people that who have bought it. And one of the really cool things about this too is that because we're using 3D printing rather than a process like casting, we actually have them printed with our logos on them. So if, in the future, we're planning to do some special edition clubs and throw those out there to say, hey, if it's 4th of July, here's a 4th of July club. We've got a major tournament, here's a major tournament club. We don't have to pay for an entirely new mold for that club head. All we have to do is send a file with updated graphics. And because the club head itself is the same, we can print them with whatever we'd like on them, and it'll still come out exactly the same because of the way that they're fixtured with the printers. And then also, I think one of the cool things here too is that they're able to assemble them for us. So, we have separated the hosel and the head, and when we get those are kind of assembled in as well, which is just fantastic. And then we also get to make left-handed. So one of the big things with golf clubs is, you've got right-handed and left-handed depending on how you play. And so the left-handed club is basically always going to be a mirror of the right-handed club. And so if we were to use a process again like casting, or if we were going to CNC, we would have to have a whole separate process and a whole separate thing for left-handed clubs. With these, we can just send the left-handed file and the supports and everything are still the same. So we're able to print right and left-handed with no additional cost to us. And it allows us to have that ability to say, hey, yeah, if you're a woman who's left-handed, don't worry, we got you. You can still have the exact same equipment without having to even, shrink what we offer there or not even offer to lefties. And then with polymers, so we use nylon 12 for this, and we get these 3D printed on the 520 printer. And what's really cool about the polymers too was that this part, the tech slot, was probably our most complicated component when we were designing. We had, we had to fit within that range at the bottom of the club. We had to make sure that it would, support itself and stay internally. And so we went through a lot of different design changes with how we were going to lock that into the club head itself, and went through and figured out, okay, yeah, we lock it in from the sides. We adjusted the club, the head itself during the design phase to make sure that that would work. But then when we were coming up with something to print, because we had to lock in from the sides, we ended up leaving really thin walls in a lot of this part. So, in the areas where you put the weights, the 3 slots, you can see you've got like really thin walls on the front and back ends of it, versus the sides are a little bit thicker. And with other processes like injection molding, we had explored making this component, but they told us, we have to add draft angles, we have to add, thickness to those parts to make it, workable. And for us, that wasn't going to work because we were dealing with such a tight space within the club head. And we also needed the weights to be a certain size so they could hit our weight markers at each individual weight size. So the only process that was going to work for us was 3D printing, but a lot of the ones that we had either 3D printed on our home printer or had reached out to other people and gotten them done in kind of the, your typical extrusion way, we would have issues with, either matching the curve of the actual bottom of the club head because it has to sit flush with the club head, or we would have issues with the hole sizes themselves for the weights either being too big or too small, or support material being left inside. So none of that was really working for us until we ended up sending this part to a contract manufacturer at HP. And they were like, oh yeah, this is no big deal, especially with the way that the binder jetting prints. They come out perfect for us every single time. And the best part is that we can get all of our finishings done for these as well. Since it doesn't print this really pretty pink color that matches our logos, we actually get them dyed or Cerakoted to match our logo color. So we're able to get all of our color matching and everything done. So all the parts come in perfect every single time, exactly the same color. They fit our logos. They look exactly how we wanted them to originally, without us having to get custom plastic made, or having to pay for these molds and things where it just wasn't going to work for us. And then what's really cool too is that because of the way they attach, so these tech slots actually screw into the bottom of the club. So we're able to get all our heat set inserting done on these components too. So that way we're able to screw them in and lock them in the exact way that we wanted when we're for producing these clubs. So it's just been awesome. And then one of my favorite things that we got to do was combine the two technologies and use both polymers and metals to make our weights. And so we have 4 different weight styles. And originally they were designed so that the weights would be made with plastic, aluminum, titanium, and steel. But if you know anything about manufacturing, titanium is ridiculously expensive, especially to get machined. And so we needed to find some way to replace the titanium weights. And in doing so, we were talking with our manufacturers. We said, look, we're working with this much space here. We originally were using titanium. It's not going to work for us. We want to find a way to just make this really easy to produce. And they said, oh, well, we can just make it make weight by combining the technology. And so, for the weight that we would originally have titanium, which is now on the left, we actually have a steel outer body with a polymer insert. And so, and then for the weight that originally was going to be aluminum, because we figured, okay, well, if we're doing that, we might as well just 3D print them all. We have a plastic outer body with a steel insert as well. And these are both, nylon and stainless steel 316. And so we worked really hard with our manufacturer to figure out, okay, if we've got them at, 4 grams and 8 grams, then we need to make sure that each weight is always going to be 4 grams and 8 grams. So by combining the tech, we were able to push them together. And so we'd have enough nylon and enough steel where combined it would be exactly 4 grams and 8 grams every time. And I think, shout out to the manufacturer because they had the awesome idea of actually using our logo as the center insert piece. Because originally when I was experimenting with it, I just had like a little square part. And they were like, oh no, we could do your logos. We can make it even more detailed, which is awesome. So now, the 2 grams, the 4 grams, and the 8 grams all have our heart logo embedded into them. And then our 12 gram is just straight a steel square. But we were able to make our small amount of space work by combining these two technologies. And we originally launched the club back in October. We did a quick small batch launch with our with one of the CMs, and they sold out almost instantly. We probably had them up for only about a week, and we sold out completely. So it's been amazing to work with HP and to get this technology up to the point where we were able to do a small batch, sell them. And lately we've been working with HP a lot on growing our supply chain because we've had a lot more demands for the clubs. We're getting ready again to get them back out on the market. And so we wanted to work with HP after that sellout to say, hey, this is going to be a bit bigger than we thought. How can we work with you to make sure that we can get ramp production as quickly as possible? So that's what we've been working with them on lately, and really just growing our supply chain, growing our business so that we could get to the point where we're able to produce these as often as possible. And they've put us in contact with the right people and the right manufacturers to make sure that that is going to really be able to grow with us. And we've worked now with contract manufacturers who are growing with us as we get ready to go. And so what's next for Club Grow Golf is right now we're working with HP on mass customization of the clubs. So we want to be able to offer the ability for you to say, hey, I want my name on this, or I want a certain score, or I want, something cool on that, for you to be able to order it with whatever you want. And then also in the different PVD dye colors that we've been experimenting with, and different, logo colors. That way we can have that, because, we did a little bit of this for our first batch that we released. We called them the Founders Edition clubs, and every club came in numbered. And because of the way that the HP tech works, we're able to make those adjustments so quickly. So we're working with HP on how to make sure that we can do that on a larger scale. We're also working right now to make sure the Monarch putters will be available in stores and on courses. So we're starting in Texas. We're hoping to grow and get it to the point where we can be in some of the big box stores. We also have 3 new putters that are currently in development. We're working with HP to make sure that those are going to be, as printable and repeatable as the Monarch putter currently is. And we have one that we're hoping to put out in November, and then the other 2 will come out next year. And we're also working on developing a full bag of equipment using HP's 3D binder jet technology, because I would love to have, irons, wedges, drivers out there that are all made using this new technology, because we can do so much customization to it. So I want to see how we can really go further and push the boundary on what can be 3D printed in golf. And so if you'd like to stay up to date with everything Club Girl, I'd love to invite you to follow us on either LinkedIn, Instagram, or Facebook. We'll be posting more about how you can connect with us, different sales and deals that we have going on, and then pre-sale launches as well. And then we are also going to be launching the Monarch pre-sale. So officially it launches on the 28th, but for everyone who joined the webinar, we're going to be launching it today for all of y'all. We're going to give 15% off using pre-sale code HP15. This code will be valid from 3/31 or up until 3/31/25. It should be valid as of right now. And we do ship internationally, so this code will work for international purchases. So you can scan the QR code there to get access to Club Grow Golf and to our website. And I just want to say thank you again to HP for everything, and I think we can open the floor for questions.
Amazing. Perfect. Thank you, Katie, and thank you for sharing your story with us. It looks like we did have a few questions come in that we can address here. The first question, what software do you use for designing the golf clubs?
For sure. So to design the clubs, we use Fusion 360, and it's kind of a combination of that's what we use at Texas A&M, but also it was going to be the best way for us to do it because we actually have access in Fusion 360 to all the different materials and design stuff that HP uses. So we're able to test when I'm designing, I want to make sure that everything makes a certain weight. And so I can go into the Fusion 360 library, and it actually has like HP's, stainless steel 316L in there, which is what I'm using. So I could just pop that into my design, and it'll automatically show my design in that material, so I can check to make sure, yes, it's going to hit the weights that I need, or it's going to or if I'm off, I can adjust it, and it'll stay and show me to make it show me that when I'm manufacturing, it's going to come out the way that I need it to.
Nice. From digital to part in hands, right?
Yeah, exactly.
Nice. Um, can you recap what specific factors led you to choose HP's 3D printing technology?
For sure. So when I was working with other manufacturers, I was seeing, we were having issues printing certain components or just machining them in general. And so the main reasons we went with HP was because it was going to be the most cost-effective route, as well as
Hmm.
our most viable. We were going to be able to print as many clubs as we needed to that were going to come out perfect every single time. I think on the last batch we had like 95% accuracy in every single one of our prints, and all the prints that we got in, lately have been fitting perfectly. Like we can put our pieces together and we're not going to have any issues. And then the best part too is that we can make adjustments, right? So we can do all of the customizations that we'd like. We can have, the club, it can have a different logo on the bottom, or we could do special edition stuff, and that's not going to cost us extra in the long run or have to make new molds. And so it was
Hmm.
really easy for us to say, okay, yeah, the other manufacturing besides 3D printing isn't working. And then we have manufacturing that is 3D printing that's also not working, but HP's binder jet tech was the only one that it worked perfect for us. Everything came out the way we needed to, and yeah, and we can do this repeatable.
Yeah, nice. That kind of leads into the to another question that came up. So what kind of changes did you have to make when switching to a binder jet process?
For sure. So we had to make a couple small changes, nothing that actually affect the major of the design. The biggest change that we made was we separated the hosel and the head, and then we add them together in post-processing. And this change was made because one, it allowed the club to print more consistent, and so we could get, that hole at the bottom, which is really our biggest factor to print in the exact size that we needed every single time if we had that separated, because it allowed for more print orientations. And then it also became a super cost effective way for us to do it. I think we save,
Mm.
$150 a club head by separating those two and adding them together. And it makes no real adjustment to how the club performs at all later, because of the way that they connect. So that was kind of the big change that we had to make. But other than that, we made real minor changes. We made the logos just a little bit deeper, so it was easier to paint, because you can see kind of in the club on this one, that's me and my mom having to hand paint our first couple prototypes there. And so when
Yeah.
when working with our CM, we were able to actually, make that hole a little bit deeper so that they can take care of all of that for us. And when I get the clubs, everything's perfect, so we can just shaft it and ship it out.
Yeah, just like with any startup, a lot of elbow grease at the beginning, right?
Yeah, yeah, it's definitely been like a lot of me, my mom, my friends putting clubs together. So it's been amazing to work with someone who can actually, take a lot of that off my plate. And once, when I get a club head in, all I have to do is fulfill an order.
Nice, that's awesome. I think another question about your actual design of the putter head. So it says the
Hmm.
transition from club head to handle starts out with a rectangular cross section before morphing into a cylindrical receiver for the tubular handle. What criteria called for this rather than a rounded or curved profile directly from the club head?
Oh, are we talking about, so with the hosel design, we came
Hmm.
up with we use like it's called a plumber's deck, right? So it's a rectangle coming up into the cylinder, which holds the shaft. And so the shafts are always going to be a cylinder, right? And they're all of a given size. So when we were designing the hosel, we went with this design's called more of a plumber's neck, is
Hmm.
the like slang term for it, because it gave the club a little bit of toe hang. And so one of the really cool things about the way that we weight it is, a lot of people who play with mallet putters that I've talked to have always wanted to play a blade because of the way that their swing is. So there's two different ways that you can swing a golf club, either on an arc or straight back, straight through. And
Hmm.
so when you're playing with an arc swing, you play with a mallet or with a blade, versus straight back, straight through, you play with a mallet. And so when we were designing, we designed around that arc swing, because when we interviewed with women, we found that the majority of them were playing with blade putters. So we started with the blade. Spoiler alert, is the next club that we're coming out with will be a mallet version, but we went with that plumber's neck design so that we could fit that curve. One of the really cool things about this club, though, is that for people that do play with a mallet, depending on how you weight the club, and as part of the fitting system, we can actually get rid of the toe hang or add more. So if we get rid of the toe hang completely, you can actually have that straight back, straight through swing and play with this golf club. So if you're a mallet player, you'll actually find that you'll have a lot of success with the Monarch putter versus any other blade out there. So we went with that style because it's what fit best with the customers that we were originally trying to reach. And now, our next club will be a mallet putter, so it'll have a little bit of a different way of inserting the shaft into the club head, and that'll allow you to have kind of the flip where you can have either negative toe hang or have more toe hang with a mallet putter.
Nice. Well, and then with all of this with 3D printing, have you noticed any improvement in part quality, durability, or performance compared to your previous methods you tried?
100%. So we used to, when we machined these clubs, we used 303 stainless steel. When we 3D print them, we use 316L. And I actually recently did a comparison between the two. And with the 316L, and I think with the putter design that we have now, we were actually able to thin the wall between the face and the tech slot itself a little bit more. So we have that nylon insert in there, and that actually has allowed us to give a little bit more forgiveness on the face. Because the entire face isn't, one block of steel behind it, you have the little nylon barrier between where you have each of the weights. It actually has a slightly softer feel than a straight milled face. And so that was something really cool that we got with these 3D printed ones, was we were able to up that softer feel because we were able to go thinner on that wall face.
And that thinness you were only able to achieve through additive manufacturing then, correct?
Exactly. Yeah, we couldn't, when we were machining them, especially with the shop that we were working at, they said that there was a barrier. So we had to shift that slot down a little bit so that it would be a thicker area between the two. With the additive manufacturing, we could get as thin as we wanted. And same with the plastic components, we could get a lot thinner on the walls than with any other manufacturing process.
Got it. And now with 3D, has it helped you scale your business and of course improve your customization options?
Yeah, completely. So we have been able to set things up so that we can scale to as large as we need to and start as small as we want. So like we did our first round, we sold out super quick, and now we're gearing up for this next round of sales, and so we're able to scale as quickly as we'd like. So the next round we're hoping to order at least 100 to hopefully goals is 500 clubs, right? So if we could order that many, we're able to push that number to the point where in a few months, if we needed to, we could be ordering thousands at a time. And so it's really a process that works with our ability to scale, since we are fully self-funded. We're in that startup mentality, right? What we sell is what we're able to buy and then some. And so it's really allowed us to say, okay, like we can grow at our own pace, and if things take off in 2 days, I'll be able to follow that trend. Or if it takes a year, it takes a year. But either way, we're able to really grow on the route that'll best suit us.
Nice. We had the question, why is it called the Monarch?
Okay, yeah. So the story behind the Monarch is pretty cool. So my grandfather growing up started a hair care business, and he he always kind of had a thing with monarch butterflies, and so he's the original entrepreneur in my family. And right when I started working on this project, he had just passed. And so every time that I was working, or I was seeking like some kind of guidance, or I had hit a roadblock, I always saw a monarch butterfly, and then I would understand where I needed to go forward, what the solution to whatever problem was that I was on. So this club is like my tribute to him, because I've found that he's been my guardian angel throughout this process.
It's a testament to his legacy then, and his entrepreneurial spirit being passed on to you then.
Exactly.
That's amazing. Thank you for sharing that.
Of course.
A few other questions have come in. Let me
Hmm.
see. what testing methods do these clubs have to go through, or is it all simulation like FEA?
So we do a few different testings. We did do simulation testing through Fusion to make sure that we did, have certain stress and you would check our stress areas, make sure that everything was good. But the majority of the testing that we did with these clubs was to create our fitting system and to see like, okay, yes, if you put this weight here, it's going to change the club in this way. And so if we have more weight in the toe or the heel, how's that going to affect your club hitting? And so our best way to test it we found was to put it in other people's hands because this club is about customizing to the user.
Hmm.
We had to create and test this club around the user, and so that was the majority of the testing that we did was all player testing. But then these clubs also have to go through USGA testing. So we submitted one of our earlier clubs to the USGA, and it took about like 6 or 9 months, and they came back to us and said, okay, yeah, it falls within the rules because we have to design these clubs to fit within the rules of golf. And so they have rules about how much adjustability can you have,
Hmm.
like can you put adjustability in a putter, because this is one of the first clubs to come out that has actual adjustability within a putter club head versus a driver. They have the weights usually that you can adjust for. And so we had to work with the USGA a lot on that to make sure that this fell within the rules, and through their testing didn't exceed certain limits or met certain minimums that they have. So we had to go through all that testing along with all of the testing for to make sure that our system worked and that the club actually did make an improvement with players.
Got you. Okay, thank you. Now, another question. This might be a question for um, our HP Metaljet application engineer, who is also on the call. His name's Khanh Nguyen. Khanh, how long would it take to print one of these putters on an HP Metaljet machine?
Um, Really, that we try to set up our equipment around a manufacturing process or manufacturing kind of schedule. The height of our build bed is 170 millimeters. If you want to go all out, really, you can fit like 60 parts in a build. But if you want to take like a 3 shift, 24-hour kind of work day, I would tend to recommend printing about half of that, about 30 parts. And that will allow you to start a print in the morning, like a Monday morning, and Tuesday morning when you come in, uh, all the parts to be ready to be pulled out of the build bed and into the sintering furnace. So the way we set up our build bed and the way the additive works is pretty flexible around your work schedule, the work schedule that you have. So that's why a lot of the CMs are gravitating towards our system because it's pretty flexible, based on the other work that you're doing and really the geometry that you need and the output that you're looking for. But it's really tailored around 8 shift work, 8 shift 8 hour shift, 3 shifts a day, 5 days a week. So in short, you can get about 30 parts in about 24 hours.
Wow, a 24-hour turnaround from design to part in hand, then from pressing play on the printer to having that part in your hand, right?
Yeah, having that part as a green, then in another 24 hours to sinter it. So in 2 days, you can get fully sintered metal parts, about 30 of them on this design. Yeah.
Wow. And just kind of a recap, the binder jetting technology, it is a powder-based system, correct?
Yeah, it's a powder-based system. So what we do is we layer a thin layer of powder and then print on it. We typically use a 50 micron layer of powder. For perspective, a thickness of a piece of paper is about 100 microns. So we spread out 50 micron layer of powder. We print on top of that using our traditional print head that you will see really in your 2D printer at home. We repeat that, thousands, tens of thousands of times until we get a full build bed. And within that build bed of dry powder is within that powder that we would have to excavate out. We
Hmm.
have automated machines that would help with that. After that, We put it into a sintering furnace that removes the binder and solidifies all the metal particles together. It shrinks about 20%, and the shrink rate is very predictable and repeatable. It densifies to be about 99% of theoretical density. So what that means to customers like Katie is anything you can do to a traditional, metal component, cast or machine component, you can do to our component, right? You machine it, you heat treat it, you can PVD coat it, and it will behave the same.
Because it achieves that 99% density you were talking about.
Yes.
Amazing. So another question that came in, probably still for you, Khanh. So if you're scaling up to thousands of golf components, is there a limiting factor around from a cost point of view?
No, actually, the more you print, the cost should actually go down by because of scale of economy, right? In other technologies like casting, maybe metal injection molding, the higher volume you get, uh, you will probably may need to invest in more tooling, more hard tooling, right? Because one metal injection molder can only produce a certain amount, at a time. Where in 3D printing there are no tooling involved. So in theory, the more parts that you require, the lower the cost should be in terms of piece price.
Yeah, because the powder-based system, the more parts you can fit into that build volume, the more effective it is.
Yeah.
Amazing, got you. Um, Thank you for that, Khanh. Katie, a couple more questions here before we close up. So, what advice would you give to companies considering integrating 3D printing into their production processes?
For sure. I think, if you're considering it, definitely, reach out to someone working, at HP and get their take on the design and how it could work. Because I think, I was a bit hesitant at first to go the 3D printed route. Most golf clubs aren't 3D printed. They're made, with casting or machining, and that's just kind of been the standard. But it's actually way more practical, especially from our standpoint, to 3D print these, and it made a lot more sense for us to go this route. And so, when I reached out to Khanh originally and we talked a little bit more, I understood, like, yeah, this is 100% going to be the way we're going to go. So if you're thinking about it, I'd say, reach out, talk to someone about it and see, because I was thinking that this was just okay, it's a maybe, and it ended up being our this is our for sure. So I'd say, definitely talk with people, figure out, if this is going to be best for you, because odds are it probably is.
And I think the final question we have for you then, Katie, is since you're a startup and kind of a solo entrepreneur, definitely a family business, how was it working with HP, considering that HP is such a large company?
It actually has been fantastic. I have loved working with HB. I've loved working with all the people here. Everyone has been so helpful and so understanding. Like, I'm a startup, but I'm also a student, right? I'm in my senior year at Texas A&M, and so everyone has been real understanding of like, hey, Katie, we need to, talk to you about this component. Okay, I'm sorry, I'm in class till 2. No worries, we'll hop on a call after. And so they've been like super helpful in that end, but then also in explaining the technology to me, because while I've worked in golf for about a third of my life, this is my first time really putting my degree that I'm still earning to use it in the manufacturing area. So, they've been really helpful with explaining the technologies to me, explaining the processes, showing me, more things that we can do on the club that I didn't even realize. Like they're helping me a lot right now, especially with the mask customization. I didn't realize that we would be able to set it up so that if you want your name on a club, we can do that. And so they've opened my eyes to how much we can do, and have really helped me work through, the process of, okay, we're going to take this from, this is your little prototype to this is production, and have really, they're a large company, but they feel like part of my family. So it's been really great to work with them and have them show me, the best path to grow and to produce. And it's been fantastic.
Amazing. I appreciate that answer, Katie. And I know everybody here at HP 3D Print also appreciates you. Thank you.
Yeah, no, I love you guys, for real. Y'all are the best.
So it looks like we're just about at time. At least we're done with the Q&As that have come in. But before we leave, I want to get a little more information from our attendees. I'm going to start a poll here real quick, but what are you most interested in now that you've heard Katie's story and about her partnership with HP in her design journey? I'm going to go ahead and launch this poll now. So after this webinar, I'd like to purchase a Club Pro Golf putter, connect with Katie and her team, talk with HP about their polymer printer, talk to HP about metals, or I'd like to do nothing. I just wanted to hear her story, which is completely fine also. I'll give everybody a couple seconds there. While you're filling that out, keep in mind the next few days, you'll receive emails from HP, including today's replay and previous webinars for both our polymers and metal solutions, including a link to HP's Beyond the Forge webinar series, a collection of short webinars discussing the main topics you need to understand about printing with the HP MetalJet solution. You'll also be connected with Katie's team in case anything else comes up that you'd like to discuss with her. I'm going to go ahead and end that poll now. Perfect, got that. Well, thanks again, Katie, for sharing your story with us about Club Pro Golf, where it started, what you're currently doing, and the future of the business. I appreciate Khanh as well. Thank you for giving us additional insight from HP's perspective. Please remember to use code HP15 by March 31st, 2025 for that exclusive 15% off your Monarch Putter purchase. I'd like to thank everybody for attending, and I hope everyone has a great rest of your week. Thanks, everyone.
Thank you.